Good morning everyone, I am Mr. Ish. When you're looking here at this particular question here, a system of linear equations, there are multiple ways you can solve this, but in this video I want to use the inverse matrix algebra technique. And before I forget, thank you for watching this video. I've in the past presented a video on how the basic technique is for an inverse matrix, where we talked about the identity matrix for a 2 by 2 matrix. A 2 by 2 matrix has an identity matrix which is basically 1 0 0 1. That's your identity matrix, which applies to a basic 2 by 2. This is a 2 by 2. There are 2 rows and 2 columns. There's a specific technique other than substitution, elimination, regular matrix algebra, the inverse matrix technique. If you're looking at a basic equation such as this form, and let me very easily generalize here in terms of coefficients, we're looking at something which looks like this. And then let's use another letter here, and then we'll have this is equal to y. You know, when you're doing the setup for matrices, you're going to bring out these coefficients. You'll have a, b, c, and d. These are your matrices. But how is the inverse matrix? Like, what is the basic premise of this inverse matrix technique? You're doing all of this. This right here represents your A matrix. Just I'm using that as a designation. Here you put your identity matrix, which is symbolized as that. You're going to solve this such that you'll get your identity matrix right over here, and your inverse will come out here. This will get converted by means of a series of rules and procedures to your identity matrix. This right here will become what will be your inverse matrix. The basic premise is you'll take your inverse matrix which you've calculated, you multiply it by your b values. We'll talk about what b is, to get your x values. That right there will represent your solution, x comma y. That's exactly what it is. But what's b, what's x? B are exactly what you're seeing right over here. These values which were equal to, here's 2 and 0. That's your b values, that's your b. What's your x? X will be exactly your solution of your system of linear equations. You know, a is coming here from the coefficients of these. You're doing through this procedure to get that. You'll end up here multiplying a 2 by 2 matrix with this, which will be a 2 by 1 matrix, a column matrix. You know, when you're looking at this right here, if you were just to put this into a matrix, you have 2 rows and a single column. The inner numbers are the same. Therefore, you can do this matrix computation, the multiplying, and your end result is always by looking at the outer numbers. It'll be a 2 by 1 answer. This 2 by 1 answer will represent your x comma y. But when you see this specific question come into play, you will understand all of these little technicalities that I'm talking about. They'll all come to light, and it won't be as complicated as it's seeming right over here. So let's get on with this question. Set this into your coefficients. You have a -1, 3, 2, and a -1. You have a -1, 3, 2, -1. This represents your A matrix. We'll partition here and we'll bring the identity matrix 1 0 0 1. Now you have to do a series of steps to bring the identity matrix here, and you'll automatically end up with your inverse matrix. Your inverse matrix, which is symbolized A exponent -1. This right here is not a true exponent, but it's just symbolized as that. I want to get a 1 over here, therefore I'm going to do row 1 times -1, and you're going to multiply it across. I'll include the tag of that previous video where we've looked at inverse matrix in the information for this. You can always review that if you want. Here you get a 1, you'll have a -3, -1, a 0, and then here you are doing nothing, so you just write it out. I need to get a 1 0 0 1. So what my next step is to look at this and focus down here and make that into a 0. I'll do row 1 times -2 plus row 2. And look what will happen. The row 1 will stay exactly as is. 1 -3 -1 is 0. Now I'll do this computation. 1 times -2 is a -2, plus that 2 is a 0. -3 times -2 is a 6. 6 plus -1 is a 5. -1 times -2 is a 2. 2 plus 0 is a 2. And then 0 and is meaningless. This will stay as a 1. Now I've gotten my 1 and a 0. I need to get a 1 over here. So let's do this row 2 divided by 5. Remember, I need to get a 1 0 0 1. Whatever comes out here automatically will be your inverse. The first row is nothing. You're not doing anything with it, so it stays as is. -1 a 0. You have here a 0. 5 divided by 5 is a 1. 2 divided by 5 is a 2 over 5. 1 divided by 5 is a 1 over 5. Now I've made progress. I've gotten my 1 0 1. I need to get a 0 over here. And how can I do that? I'll utilize this number and look up and convert that into a 0. I'll do row 2 times 3 plus row 1. And now I'm going to bring that end result right over here. The row 2 is not being affected in any way, so you can write that 0 1. Here's your partition line. 2 over 5, 1 over 5. 0 times 3 plus that is just a 1. 1 times 3 is a 3 plus -3 is a 0. 2 over 5 times 3 is a 6 over 5 minus 1. You know what that is. Bring out your calculator. It should be a 1 over 5. 6 divided by 5 plus 1 minus is a 0.2. 1 over 5. That's exactly what it is. 1 over 5. 1 over 5 times 3 is a 3 over 5 plus 0. Well, it's 3 over 5. This box right over here represents your inverse. This box right here represents your identity matrix, and that's exactly what we wanted, is this. You've seen this procedure here before you. I'll create this space and we'll take this now to conclusion. Your concluding operation is this. You're going to multiply the inverse times your b values to get to your x. Your x will represent your system of linear equations. Your b values are exactly this right here. Let's look at our inverse, which is this. We have a 1 over 5, 3 over 5, 2 over 5, and then 1 over 5. And remember, at the end we'll check everything to make sure it's good. I'm going to multiply this inverse, A inverse, with the b values, which are this, 2, 0. Remember what I was saying? You'll be doing a 2 times 2 by a 2 times 1. You can do it because the inner numbers are the same. Then you look at the outer numbers and your end result is equal to the outer numbers, 2 times 1. And that's going to be equal to here your x matrix. Your x matrix represents your solution x and y. You're doing row with a column. You'll do 1 over 5 times 2 is a 2 over 5 plus 3 over 5 times 0, which is a 0. You'll just end up getting a 2 over 5. Then you'll do this row with that column. 2 over 5 times 2 is a 4 over 5 plus that 0. Well, it's just a 4 over 5. So my x value is equal to 2 over 5. This right here is a lowercase x. This right here is a capital X. My value for y is equal to 4 over 5. And that will represent the solution of this system. And all you'll have to do is just plug it in here to make sure it's good. You will do 2 divided by 5 minus, and then you'll do plus 4 times 3, which is 12 divided by 5, and you'll get 2. That's what I need, a 2. Now you'll do 2 over 5, 4 over 5 in this equation. You'll do 2 divided by 5 times 2 minus 4 divided by 5, and you'll get that 0, and we're good. So these solutions x and y are good. Remember, the basic premise here is you start out with what was in a template form your original A matrix and your identity matrix. You go through the series of rules as I presented, such that this now became your identity matrix. What was originally here in the A block, the A matrix, became your identity matrix. What was originally here in your identity matrix block became your inverse of A. That inverse of A will multiply with your b values, which are these, your b values, to give you your x values. This again is a capitalized X. That x right here represents x comma y, lowercase x comma y, the solution. And that's the basic premise here, and you've seen it. The inverse matrix technique is, yes, slightly cumbersome when you compare it to elimination or substitution, but again, it's still another technique that you are familiar with, or that you can become familiar with. And that's it for this video. Thank you for watching. Have a good day.